Welcome in the Energy Flexibility Forum. We are here in the Center of Architecture and Metropolitan Planning to discuss how to advance building and community management solution. I would like to as well welcome people online from all around the world. So hello. And let's start with the first question which we should ask. So why we need energy flexibility and why it's so pressing topic today? Well, the important things to realize, like we are on the way to carbon neutrality. It's not planned, it's happening. It's here, so we can see nicely like the ratio of the renewable energy sources in the European energy system is increasing. We are like the coal is on decline. We are trying to reduce this fossil fuel-based energy, and then we would like to reach in the end as low carbon intensity as possible. And this is not something like in the future; it's happening now. But it brings quite a lot of challenges, which we are going to discuss today. I think where we should start with the energy efficiency as the first principles. Well, it's already well known. We need to save energy where it can be saved. We should start with that. But we already know as well that with the renovation rate and with the rate of the new buildings to be built, we cannot succeed the achievement, like to achieve the carbon neutrality by 2050. Of course, some digitalization in this area will help to speed up. We need to pay attention the life cycle, for example, using circular economy principles. But if we if we want to succeed by the 2050, we need to take care about how to cover the demand and focusing on the heating, cooling resources and integrating renewables as well in this sector. Well, that as well brings some challenges for electricity grid or in the energy grid in general. And we would like to have resilient grid, right? We would like to have supply secured 24/7, and we know already that there is prepared a huge funding, like investment funding, to improve European grid, because they expect to increase the demand about 60% between now and 2030. Why it's going to be increased? Well, we are kind of doing this fuel shift where everything is like, or major part going to be electrified. So we are seeing like this electrification in mobility. We are seeing in the building sector. So we are integrating heat pumps, and we should think, if we add all these millions of rooftops panels, which are planned apparently, we should think of how to share the energy and how to manage it in the way that we can really use it when we need it, and not only when it's generated. So basically, to summarize it, we see the shift that the buildings are becoming prosumers, so they are generating their own energy, but it's not, of course, stable, it's intermittent. And then we definitely see some energy transition in the grid. So it's happening as well at the industrial level. So the grid itself is becoming cleaner and cleaner, let's say. And we can see like this shift illustrated by this study of International Energy Agency. So you can see that in the installed capacity, we assume quite a big portion of wind and solar, and same, it's in electricity mix. But that's a bit challenging, right? You can see this in the example, this profound duck curve. So we know that this energy is not as we need it, but it's when the weather permits, right? And then we see this profile, and for example, California has this experience already because they have, I think, a higher ratio of solar than we have here. So we can see this kind of imbalance or this kind of profile, which is very hard to supply, and then we need some flexibility. Where we can see it as well, it's like as a side effect, we can see in the market like negative prices. It's like even like 2 years ago there was some like first big news that we have negative prices. Nowadays it's kind of common things, but I don't think it's something really like good. What we need is basically indicating that the grid is in trouble, and we should try to help the grid to somehow maintain. And what we can do as a building operator, we are going to discuss. So basically, we need to shift from building as an energy prosumer to building as a flexible asset to kind of as well provide some short-term storage. And we need to find a way how to share energy among us between communities and how to store it seasonally. For example, hydrogen could be a nice example that we definitely hear. So I would like to welcome here our speakers. I would like to maybe applause for them. Thank you. Let's introduce them one by one. Well, we have here Henrik Mensen. He's an expert in mathematical statistics with focus on stochastic system from DTU, Danish Technical University, Denmark. We have Dr. Nicholas Long from US, from National Renewable Energy Laboratory. So he is expert in software development of building energy modeling with specific focus on the, let's say, big data management from this large-scale community models. We have here Dr. Stephen White from, and then help me with the CSIRO abbreviation, Commonwealth Scientific and Industrial Research Organization. I was learning that for a bit. So he's focusing on energy efficiency and demand-side management already for some time, and he's an operating agent of Annex 81 that you will hear something more in a minute. And then we have 3 experts from industry. So we have here Jan Hicl, CPO of Delta Green, which is a company which recently conducted like groundbreaking test that they used house batteries or kind of residential battery system for ancillary services for CHEPS, the Czech TSO. Then we have Giuseppe Macario from Swiss Evergreen. So this worldwide operating company focusing on EPC consultancy and currently specializing on net zero energy building and net zero energy communities. And last but not least, and only lady in the panel, and thank you that you are willing to attend against these men, Šárka Kuthanová. It's gonna be a great fight. Just kidding. So she's representing here SWW Wunsiedel. So this is actually a municipality company securing energy in the region of Wunsiedel, and they've like their own production side, their own grid, and they really have like physical community as a pilot, and they are already running it as a business as usual, we can say maybe. So we can hear as well some examples from the real like pilot. Something a bit about the structure, and we can start with presentations. Well, part 1 is building as a flexible asset, and then we have presentations about ongoing research. So first you will just listen, and then we will discuss the topics that I think are quite interested. So what can be flexible assets? How can we quantify it? How can we effectively manage, actively participate in the markets, and why to join energy community? So these are the questions that we are going to discuss, and then there will be time as well for you to ask a question before we get to the second part of this forum. So now I would like to invite on stage our kind of hosting coordinator of the hosting project Glocalflex, Klaus Kansala, which will tell us something more about Glocalflex as a project and what it's bringing here for innovation. So welcome here, Klaus.
So is it working? Yes. So first the usual battle with the technical devices and then continues. So first of all, I want to thank our Czech colleagues about organizing this event. And secondly, I want to thank them about giving me 5 minutes to tell about the project. So I try to use this time as efficiently as I possibly can. So this Glocalflex is one of this kind of EU products, and it is actually targeted for energy flexibility. And of course, in this phase, we have to be more precise about what is our aim here. So our aim is the product is actually to make it possible for everybody to be part of the flexibility markets in the European level. So that is, we are developing methods for people, households, and other, let's say, units to be able to be involved in this energy game, this market, and offer their, let's say, flexibility assets in order to help the energy markets to be, let's say, better balanced. So how we are going to do it, I'm trying to explain a little bit about that. So how to do the next slide? Okay, so it's there. So some basic statistic information. We have got a 4 years project, which we now having like 1.5 years. So there will be some results. And actually, if you want to see what is going on the project, you can scan this QR code and then you will get to the project main page. So there's plenty of information available already now. Okay, coming back to here. So we have got a very nice, let's say, project team, or let's say project consortium, like having lots of partners across Europe. I don't want to list them here, but we have got partners from, let's say, from the north and from the south and in between. And that gives us a very good coverage about this kind of different climates and zones like that. And also we have got a very good, let's say, diversification of different kind of pilot sites, starting about industrial sites, having, let's say, lots of, let's say, energy production, having energy communities there, and also having private households in the other end. So we can cover the whole spectrum of different kind of, let's say, energy users. So I think that is one of the biggest strengths of our project. And okay, let's go a little bit deeper in the system. So what are these actually pilots doing? So their main, let's say, task is to develop their own management system for the assets. So they should be able to provide flexibility assets to the marketplace, which is developed on the product, so that we can actually start to trade these assets online. So basically what is happening there is that we are trading assets. So the marketplace is actually a matchmaker. It is actually matching together the ones who has got something to sell and the ones who will buy something. So that is like, also you can relate that to a stock market. So in stock market, you can always sell and buy stocks. Instead of stocks, we are now trading patches of flexibility. And that is exactly what this marketplace is planned for. So all of these 6 pilot plants are supposed to provide their assets to the marketplace, and then we start to do trading. And once the trading is done, then you have got agreements, and after the agreements are fulfilled, then we will make a settlement, and then somebody will get paid about this asset. So all of that is planned to happen in the marketplace. And okay, I'm going ahead in my presentation. So this is how it's organized. So you can see we have got 6 pilots there. All of them have got their own assets, and they have got all their own energy management systems. And the communication from these things is actually something that is provided by the platform. So we have got a specific control structure, control algorithms and protocols. And once you can use them, you can get your access to the marketplace, and then you can start trading. So they are not committed to this marketplace. You can come and go as you please, like it said in the stock market. So there's no contracts. The only contract you will make is once you are actually selling something and your bid is accepted. Then you are under contract until you have delivered what you promised. And then there's no more contracts. So this is totally open. And also the buyers and sales, they are treated equally. So this is like a real marketplace without terms and conditions. They are all equal. And also the prices are dynamic. So it depends about who wants let's say the assets are paying the highest prices, and you will get the highest prices for your assets all the time. So it's completely open trading mechanism, which is, I think, quite nice concerning about the current situation in the markets. So private households or energy companies, they cannot make the best pricing, best value for the assets. So that is what we are going to change. Okay, I'm again going ahead in my presentation. So what is also important is that when you think about the size of the assets which will be traded on this kind of market, so we are looking for very high volume in trading, like 100,000 trades every day. But then the amount of each trade is small. Like one household maybe can sell like 2 or 5 kilowatts of flexibility once a day. So what is the size of this trading? It's like a few euros at best. So the transaction cost should be very low. So that is happening so that we are making totally automated trading. So there are no people involved whatsoever. And that is one of the key things. So, and I already talked about the pilots. So the pilots will have different kinds of, let's say, assets to be traded. And the task for them is to make their own management for the asset and for the flexibility. And then they enter the marketplace, and the marketplace takes care of the rest. So I think that is in a nutshell about what we are going to do. So thank you for that.
Thank you very much, Klaus. Thank you very much. And we will continue with another short presentation about Annex 81. Stephen will present it, about data-driven smart buildings, because as you could see, there is a lot of trading around, and then we need data for that. So Stephen, this is the ring of rules.
Thanks very much. It's a great pleasure to be here from down the other side of the world in Australia to present to you about the IEA, International Energy Agency, Annex 81 on data-driven smart buildings. Data-driven smart buildings taking using emerging digitalization technologies from Internet of Things sensors through to data management technologies, through to advanced analytics technologies in order to manage buildings better. So what is the role, if you like, of this particular annex? Our aim is to support the scalable, I've underlined scalable there, that is the ability to rapidly deploy at low cost and implement these digitalization technologies. Obviously, thank you. Obviously, we're from the International Energy Agency, and so therefore the focus is on energy productivity solutions, but smart buildings is applicable for a whole range of other things as well. And I like to break down the challenge into two components. One is the IT infrastructure component, getting your data into a place where you can use it. Indeed, we were doing a whole bunch of interviews, and it was just fascinating how much that sort of came out. You know, so a software as a service platform operator says, when you talk about analytics, it's all about data management, right? And various other sort of comments like that. But once you have your data, then you're able to deploy the analytics and the other value-adding software products. So what can we do as a community there? Obviously networking and knowledge sharing as with any annex there, and the ability then to implement standards, provide guidance to stakeholders, provide state-of-the-art reviews and produce case studies. That's fairly standard. But one of the fun things here is this annex came out of a thing called Mission Innovation and has always had a sort of a challenge to try and invent or develop, innovate around software as a service solutions. So if there's any people, maths whiz in the audience, we've got a competition coming at the end of June looking at, one is around flexibility and one is around disaggregation of loads into heating and cooling components. In terms of the structure there, we've got 4 subtasks. Subtask A is very much around that digital infrastructure component there, looking at the governance of managing data responsibly, and also around automation and machine readability so that these things can automate their actions. Then subtasks B and C are the useful applications, and I've put a little circle around activity C3, which is dedicated to flexibility and utilising data to automate flexibility. One last slide then. Sorry, that didn't come up too well there, is we're coming to the end now, and one of the, I think, signature reports that we've got is by interviewing people, reviewing the literature, bringing the expert knowledge together, we've come up with a set of advice, if you like, for governments to implement policy. We've got the near-term target of energy efficiency with savings of up to, I say up to as a weasel word, of 40%. But then you can see in the outer years, flexibility is very much the reason why digitalisation is important from a policy point of view. We've got 8 themes in terms under which we've categorised our recommendations and more detailed recommendations underneath that, involving certain things that that relate to regulation. We would try to make this cost-effective and voluntary where possible, but there are certain barriers that we've identified that require regulation. Information provision to improve awareness, trust, and other barriers. And then we have a bunch of recommendations around incentives as well. And one of the core sort of themes that came through all our interviews and all the discussion is the importance of that data management piece. And hence my sort of trying to relay a quote there before around just the importance of getting the data of a sufficient quality in a sufficient structured form to enable automation to make it bring down all the transaction costs, similar to what Klaus was talking about before. So I'll finish there for that brief introduction to Annex 81. Thanks.
Thank you very much. We need to maybe turn back just this one. Yeah. Before I give you a word, Henrik, you can stay here. Just I would like to tell you that these QR codes are kind of links to the web pages. You can find a lot of additional information. I forgot to tell it before, but from the stream you can as well load it by your phone. So now Henrik will tell us something more about Annex 82 dedicated to flexibility.
Thanks a lot, Vojtěch, and thanks for the invitation, and thanks for Rui for allowing me to introducing this important annex, which is energy flexible buildings. So, and of course, my presentation, my short 5-minute pitch here will be a little bit biased towards my view on this annex. So I apologize for that, and but we will have a discussion afterwards. So please, we can comment upon that. So first of all, why do we need energy flexible buildings? Yeah, we simply need it because we, by unlocking flexibility everywhere, and demand side flexibility, we can save up to 80% of the investment in, for instance, in distribution grids foreseen until 2030. So it's simply so important to do this in order to have an efficient and fast energy transition. So Annex 82 is an annex which is building on top of Annex 67, as I see it. Annex 67 was an annex where we considered individual buildings and flexibility. And we considered data-driven flexibility of individual buildings. We also realized that we need to take it to the next step. We need to consider clusters of buildings. We need to consider multi-carrier energy systems. And we need to take it to the next step. And that's why we, in Annex 82, applied some more simulated approaches where we simulated different scenarios, we had different use cases, and then we tried to simulate how we can unlock the flexibility in group of buildings and so on. So there are 4 subtasks in Annex 82. Subtask A is building energy clusters and multi-energy systems. Subtask B is common exercise in order to characterize the flexibility. Here we are using, in Annex 67, we used heavily the flexibility function concepts. It turns out to be complicated when we do the simulations in Annex 82. So we used other use cases to characterize the flexibility. And in parallel to that, we further developed this flexibility functions concept. We also considered stakeholders, business models, and policy. What I would like to describe also is that what we are looking into is we have some huge challenges. In my view, the way we have markets today, where we bid into the market with the block bids, is a very static and deterministic approach. So, and if a supermarket has been flexible for this half an hour, then it cannot be flexible for the next half an hour. And we also have things like private homes and also wastewater treatment plants, which has other priorities. So we need to go away from this on an end-user level, DSO level, street level. We need to go away from, in my view at least, from this bidding and clearing to more automated control principles, so it's fully automated. And also in a classical power system setting, you have a lot of different problems you should consider. You should keep the voltage, you should keep the frequency, you should take care of congestion, you should take care of ramping, and so on. And all this sometimes ends up in different markets. So we need to harmonize that. And that's why we suggest to use the generalized flexibility functions, which some of my people, for instance, Hub, who is here today, has developed. It's simply, from some level in the hierarchy, it's simply broadcast a price to the end users, which then respond to the prices, and then on some higher level, the aggregators bid into the classical markets. So this is what we have built into this combined. I also participate in Annex 81, which focus a lot on the data-driven methods. That's why what we build in what we call the Smart Energy Operating System, which is a hierarchical setting of controllers. And on the higher level, we have classical markets, but on the lower level, we need to take into account the stochasticity and the dynamics. And so we use the flexibility function to map the static, deterministic market operations, which should still exist to get the level, but we should go to the lower level to activate the flexibility and take the physics into account. So this setup somehow bridges the gap between the markets and the physics, between the classical deterministic block bidding and non-static block bidding to the dynamics and stochasticity we have on the lower level. So this ends up in a suggestion for a hierarchy of price generators, which in order to solve the different problems we have in the grids, and we can also use it multi-energy, for instance, district heating and power systems. We simply, on the higher level, we have the market clearing, but then the different players set in the prices, which ends up in a total price, which at the household level, which we consider here. So we know we can save up to 80% using demand-side flexibility. And we suggest to use this control theory and stochastic control approaches on the higher level to actually activate that. And that has a built-in, for instance, DSO, TSO, and balanced responsible party. So we have drafted a number of papers. One of the important papers here is this one led by Rongling Lee, which is the operating agent of Annex 82. So I will suggest you to contact this or to consult this paper to look into some of the critical questions and potential answers when we are going to unlock the flexibility in buildings and clusters of buildings. So thank you very much.
Thank you, Henrik. Thank you, Henrik. So that was a few presentations as an introduction. And now we have roughly half hour to discuss it, to talk about it, and as well there will be a time for you to ask a question, and then basically we will conclude the first part and let's check the industry solutions from the second part. So this is a bit teaser. But basically we get inspired by this paper, and we would like to some of the questions to be discussed. So like one of first question which I would have as a building operator, so let's imagine that I'm the one building operator which has the questions. So what can be flexibility asset in my building? We were talking a lot about flexible assets here. I'm not sure if for everybody is clear what is it actually. So maybe Stefan, can you tell us something more about what can we understand as a flexibility asset?
So a flexible asset would be an energy-consuming device that can be turned on or off or nudged up and down. And normally there would be some sort of storage element to it. So one of the classical ones would be a standby generator, which you can turn on when required. Another item might be electric vehicles. That's certainly very much an important one for the future. And we already have some sort of understanding that we charge up when the price is low, and we drive away and don't charge when the price is high. So EVs is a big one. And then batteries, electrical batteries, but there's also thermal batteries as well. And inside buildings, our air conditioning systems have got some element of either active or passive thermal battery that can be exploited. I guess two ingredients there. One is the physical ability to switch on. Another thing is to be digitally connected, because if you can't receive a signal of some sort, then you just don't know when to turn on, turn off the like. And just one last comment, I guess, from my point of view, perhaps I get a little bit frustrated with electrical batteries getting the limelight, because I've got plenty of evidence, with getting quotes and things like that, that in the right circumstances, the thermal batteries from air conditioning would be at around 20% of the price of electrical batteries.
Thanks, Steven. Jan, you already did some experiments how to actually introduce like home appliances to this kind of static market that was described here. So what do you think? What could be a flexible asset? What do you consider in your company as a flexible asset that could be used?
Yeah, thanks for the question. So I think that the flexible asset can be whatever in a household that can be shifted in during the day, that we can postpone their operation. And last time I saw a very nice example of daily life example was that on the iPhone in the US, you have the option to charge it only when the green energy is being produced. That's a very nice feature and very nice example of the flexibility. The flexibility is very small. Of course, charging your phone will not save the world and will not help us to go to the renewable energy system, but it's a nice example that like almost every single asset in your household can be flexible. Of course, it's not like important for the grid, as I said, but if we go and have a look at the statistics of the household, then we find out that like average European household consumes around 75% for heating water and heating household. And these two assets can accumulate energy, and we don't really care where they run unless all the preferences are met. So meaning I have hot water and I have warm house. Now from the perspective of the future, there are two batteries, one with the wheels, one without. With the wheels is of course EV, and without is the PV panel battery. So these are the major flexible assets, but as I said, I believe that there's going to be in the future the flexibility is going to be a commodity, the same as we buy energy or power. It's going to be a commodity, it's going to be sold on the market, and this was a nice introduction of the future market, how it could look like. So I believe that the makers will make the shift to this new phenomenon and will integrate into the fridges, into I don't know what else, like all the devices that you have in the household. So I believe it's going to be a big thing, and it's going to be everywhere.
Out of curiosity, why did you select as a first like battery for your test? What is the reason?
The user preferences are not that high for the battery. You don't really care if your battery is charged when you come back from your work. If you start with a water heater, which we actually started in our own household, and you can imagine what your wife tells you if the water is cold at the end of the day. So sure. that's not the asset you want to start with experimenting. So that's why we started with the batteries, because it's way better for controlling.
Let's not reveal that much, because you will show more in the second part of the discussion. Let's move on to another question. So the other appealing question that we have here is how can actually energy flexibility be quantified, right? So what is it? It's basically we're hearing all about like shifting energy, but how we can measure it, because the profile that we change it not exist anymore. So perhaps Nicholas Long, you can help us to explain how we can quantify it.
Yeah, sure. So thank you, everybody. Nice to see you all. So there's several ways to quantify electric energy flexibility, and I think I'll start from the consumer level, where we see energy consumption as in kilowatt hours, and we see power, kilowatts, and we get charged typically on both of those, depending on how much energy you use, and then some peaks. So the easiest energy flexibility would be just reducing kilowatts, and that's the most common way that we see flexibility. If I'm able to shed load right now, then I have flexibility. If I'm able to shed shortly in the future, then I also have flexibility, which may have more value, because now I can predict that I'm going to shed something and then move it. So now I'm shifting. So I can shed, shift, right? And then lastly, you brought it up briefly on a slide, was frequency regulation. So now you can shimmy, right? That market typically is at the aggregator level, but you can definitely shimmy. So between shaping, shifting, and shedding,
it's like
shedding, shifting, and yes, you have those types of things. From the grid's perspective, we want to make sure that we're not causing too much system ramping, right? That's a common metric that we're looking at. It's basically how much impact are we seeing the grid is seeing as an absolute. If you look at the duck curve that was showed earlier, that's a very big impact to the grid. It has to handle the ramping and then the reduction and then the ramping again, and that ramping is expensive for grids. So I'll leave it at that.
Yeah, thanks. Maybe Giuseppe has a bit other point of view, because as we mentioned, like Energy Green looks at more about the energy performance contracting. So how would you think about like quantifying from that perspective?
Yeah. Okay. Well, it's now about 12 years that we are looking and measuring near zero energy building and zero energy building. The data that we collected every 15 minutes for the last 6 hours in 5 buildings gave us the chance to create a mathematics model that gave us an assessment of the energy we need for tenants and for buildings. This allows us today to roughly design and measure what we have to design for each building. As today is possible, know before we design the building and the consumption we will have in terms of tenants inside, what we are going to looking for. This helps us a lot, because if we talk about kilowatts, we know that the building will have a consumption that is such megawatts a year, and we know that a family in North of Europe or in Middle Europe or in South Europe will use some megawatts a year. And we can plan and we can design systems that will help the buildings to be off-grid, theoretically, and work in a flexible way with the grid.
Thanks. Yeah, Stephen, would like to add something?
Yeah, perhaps I can just add that one part of quantifying energy flexibility is how do you get paid? Or how do you make money out of this? And I kind of see 2 ways of doing that. One is I just continuously modulate my flexibility as part of my time of use tariff. I just multiply the kilowatt hours that I consume by the time of use charge, and I get a lower bill. And that is kind of a simple way that's a relatively easy way of quantifying. And then the other way is where you say, well, no, I've been called for an event that is, please do this between these hours and I'll reward you on the difference. And then you've got to measure some sort of baseline of energy consumption. And you do that by learning the behavior of the building and then projecting that forward and comparing what you otherwise did. And that is a little bit more fraught, lots of sort of uncertainty, but it is something that is very important for managing the security of networks.
Okay, thanks, Steven. So we know how to quantify it, or
well, we don't. No,
we don't. Okay.
I believe that we do, but we work with the end customers, and we really struggle to explain them what the flexibility is and how to quantify it and how to measure it. And of course, the question is at the end of the day is how much I can make from the flexible asset, how much flexible they are. And I want to understand if I have this water heater in my house, if it has 200 liters, and I consume 50, how much can I make on it? That's the basic question. And I believe that I'm kind of missing the unit for flexibility, like very simple one for the end customer that I can go to him and tell him, we can measure your water heater and we can tell you that it has this much of flexibility and this is the unit. And because of this unit, we can give you this much money. So we understand, of course, what the flexibility is. We understand the struggles behind it, but like talking to the end customers, it's very hard and we still don't have the way to explain them.
Yeah, Henrik?
Yeah, probably many of us know the Smart Readiness Indicator, which is a table-based method to look up what you have in your building, and then you come up with some figure of smartness. The problem is, of course, it doesn't really link to reality and to the data-driven methods. But that's where, in particular, Annex 67 and partly also Annex 82 brought up the flexibility function and the flexibility index. And in particular, the flexibility index is just a simple number which can tell you if you are having a ramp rate or the dock curve problem, the peak problem in the California, for instance. Then you can say with this design of your building, which contains a lot of assets, you can save maybe 20 or 40%. If you live in Denmark, I come from Denmark, our main problem is we have a lot of wind and we need to accommodate that. So we can have a flexibility index for wind, which we typically achieve by having a lot of district heating connected to our, both electricity grid, of course, but also district heating, TSOs and DSO and the coupling.
Is that the formula with the integrator, right? No, it's not? Is it that easy to calculate, really?
It's, in my view, it's very simple to calculate. So as soon as it's just to have a price-responsive control and a control which is not price-responsive. So it's sure. Rather trivial.
You touched the topic control, and it leads us to the new, another question, which is very related to what we just said. Okay, we are not sure how to quantify, but we heard baseline, and apparently we know how to calculate it, but we are missing some simple unit. Maybe the flexibility index could be the one. And you mentioned several times the flexibility function. So how it can help us to kind of effectively manage the demand side?
Yeah, I will be happy to elaborate a bit more on that. Of course, today we're probably focused on buildings, but the smart energy operating systems, which I briefly described, we are using that also for cool storage and wastewater treatment plants, supermarkets and industry and so on. So the way I see it is that we have these flexibility functions which maps the conventional market, which we should protect, of course, to the low-level dynamics and stochasticity. That's the flexibility function. And it can be used to map both ways, the function and the inverse function. Sorry for the mathematics here. But that's done. That's easily done. And for instance, if you consider wastewater treatment plants, they use a lot of energy. We tried some years ago to convince them to participate in markets. But they will never participate in markets because their main concern is to avoid overflow in the street of Copenhagen, whatever, and to also maintain the active part of the bacteria inside the plant. So the third priority, or fourth maybe, is to save energy by being flexible. But most of the time, they can be extremely flexible, and they can actually save 50% of the CO2, the carbon footprint, by doing this as well. But that calls for the use of the flexibility function and simply reacting to prices. And if they have a thunderstorm, the only concern is the thunderstorm. Just to take one example.
Yeah. Yeah.
So this is. In order to activate flexibility everywhere, I simply think we need this hierarchy of controllers which take care of different problems in the different grids, both heating grid and gas grid and electricity grids, of course. And then we should have a dynamic pricing scheme, simply.
Thanks, Henrik. Maybe now it's time to give word to Šárka Kuthanová, because at Wunsiedel they have already some experience, right? So, like we called about demand side, behind the demand side there we have people, right? And we need to somehow work with them as well. So, what is the reality? How we can kind of manage the demand side, or what is the experience in Wunsiedel?
Yeah. Thank you for the question. Hello from Wunsiedel, from SWW. We are already doing this flexibility, and the key word of our boss is we have 100% flexibility in our power plants we are providing. And the first question we had to answer few years ago was how the people will react if we have such flexibility in our municipality. So you shouldn't forget about the people, about the households, about the wives, about the coffee in the morning, let's say. Of course, the equal rights should be also involved in this topic. Partnership. It's also one of the keywords. It's real important in the flexibility and also in the flexibility market. Because if you want to create flexibility community and flexibility power plants in your city or in your region, you need a real good partner in the whole area. And no one should be feeling like I'm not the part of this community. I know it's another side of the flexibility, but we have already the technical solution in Wunsiedel, and to the technical solution we have real nice stakeholders. They are engaged in this topic, and we also took our citizens with us.
We will see as well example of implementing Glocalflex in the presentation later, right? So thank you.
Thank you.
This is just a reminder that demand side, it's of course we would like to keep it as a control, but we have as well people behind that. You mentioned market several times, and that's another kind of question, right? We are talking about like we need to like kind of make lower barrier markets and so on. So if somebody like from the residential sector wants to be active, so how to actively participate in the market? So Stephen, I think you will be the right person to answer this question.
Happy to have a go at least. I don't think it's anything more complicated than looking to your energy retailer or aggregator for a plan. You know, we go to our telecommunications thing, and you get a mobile phone and you get a plan, and so that would be the normal way, I guess. And indeed, I don't know, in Australia and in many countries, we've already been doing this with our hot water systems. And in Australia, we've had a renewed interest, I guess, in hot water systems because we need to now, because we've got so much solar PV on the roof, we need to absorb all that solar, and instead of having our off-peak or flexibility at night to get our cheap energy, the cheap energy is in the middle of the day. So I think it's as simple as that. You know, get a plan with your retailer or aggregator, and they may install a device, because as I said before, you do have to be digitally connected in some way, or comms connected in some way, to be able to activate your device.
Thanks. Perhaps Jan, you have some like real-life experience how to maybe introduce like the end user to ancillary service market, but there are other markets, right, to be enter.
Yep.
What is your recommendation?
Of course, to join as a customer our company, because we will connect you with the market. But maybe a quick introduction of the history, because the flexibility was available only to the biggest guys in the market, in the grid, with the big power plants. Now the EU is shifting the limit for joining the flexible market to 1 megawatt. It used to be 10 megawatts in Czech Republic. I think it was the same for the most of the Europe. Now we are in a 1 megawatt block that you can connect to the flexibility markets. But we have the aggregators, and we are the aggregator. So we are now talking to all the customers, and we are asking them, do you have the water heater? Do you have the EV? Do you have the batteries in your PV panels? And connecting them to these markets. Of course, there's going to be more and more of them. But as I mentioned before, I believe that in the future, you will maybe not, and I'm like shooting myself in a leg, because you might not need an aggregator in the future, because the asset will be that smart. It's going to be the IoT device that's going to be smart and will be able to bid the flexibility for you, which will be bought on the other side from someone, and then you will receive the money, whether it's going to be through the Glocalflex or the blockchain or any other solution. That's the question. We will see in the future. But there's going to be the participation now, which is kind of tricky right now, but the future is this system.
Yeah. Henrik? Yeah.
Yeah, the way I see we should participate in energy markets from, for instance, energy community side and so on, is simply to expand what I showed with the TSO, balance responsible party, so with the energy community and smart home management system. And I fully agree with what has been said. The housewife, the man, we would like to be in control. And if we want to decide when we turn off the television or whatever. So in my house, the boss is my wife in many respects. Probably she will say that I'm boss in some other ways, but we will be in control at least. And so I fully agree with what has been said. I also think that I also agree with what Jan just said. I think that many of the aggregators and the balance responsible parties could actually be automated. So we are doing that. For instance, if I take again, sorry for taking the wastewater treatment plant as an example, that's where we are doing this together with Veolia in France. So it's running in a lot of cases. But we need there a specialized aggregator which knows about wastewater and knows about the priorities with thunderstorms and so on. So I think we are very much in line with the Glocalflex people, or at least I am. So.
I heard a lot of like this kind of that the end user should be more active and so on, but then there is kind of parallel line about community, or at least seems to me a parallel line, but maybe I'm just confused. So there is well energy community, right? And then how this goes together, and why I should even like join some energy community. So again, you have like real life experience. So Šárka, please could you tell us a bit more?
Okay, thank you. Why to join an energy community? The opposite question is why not to join an energy community? The energy community, what we have in Wunsiedel, we can say to our citizens, the money is the keyword. It stays local, so the money stays in Wunsiedel. With the energy community is also know-how in touch. So the know-how stays in the energy community. And also the technical part, so the plans. And you can create quite interesting places for your citizens. The flexibility is on site, and if you join a community, energy community, you could feel safe
Okay.
in your...
So the community helped me to kind of be more active at the market because we are kind of together and kind of
Yeah.
have a bigger voice. Is that the
it's
way
the
how to see
bigger
it?
voice. You can save your grids. You can save your money. You can save. You can also you can feel safe in your houses, in your households, and it's consumer prosumer solution, local.
Yeah.
So if you feel okay in your home, in your company, in your region, then why not to join an energy community local?
Yeah.
And if you have a local energy community next to another local energy community, then you have a bigger flexibility.
Okay, nice.
Okay.
Maybe
Thank you.
Giuseppe as well, design and like you are in the field for some time already. So what you would recommend why to join energy community?
Well, we have the same experience of Wunsiedel community. When we started in 2012 to design near zero energy building, we were just thinking about a building that was able to satisfy the energy needs with photovoltaic and batteries. And we make an error because we forgot that having prosumer inside the building was the best chance to not use the batteries. Oh, I do not mind. We have to use batteries, but if we have a near zero energy building or a zero energy building that use battery and we use prosumer inside, we have a bigger opportunity to be local, and to save money and save the battery cycle. I don't know the experience we have in this room, but in the last 12 years, we changed 100 equipment of batteries because batteries was with a lot of trouble. And day by day are more reliable. The cost went very down. Today, you can make an investment, a cheap investment, and probably you will achieve a payback. But in the past, the batteries was a trouble. So I would say that use energy community is a big opportunity that we cannot absolutely avoid. We need to create energy community because this care of our environment.
Okay, thanks. Perhaps what academia thinks about the whole concept?
Well, I mean, I'll give you...
green and it is nice. So, Nicolas?
Yeah, I absolutely think so. I think through a case study with Whisper Valley in Texas, about 1,000 homes interconnected together that have geothermal heat pumps. Typically, it's 13 kilowatts peak with a normal house. It peaks about 4 kilowatts. Interconnected loop. Each building has its own borehole thermal storage, right? When the superstorm came through in Texas, temperatures got really low, which is not normal in Texas, and a lot of the grid went down. However, this community, because their demand was so low already, was able to stay up and keep the houses warm. They're sharing energy. So not only is the community sharing ideas and thoughts, but they're sharing energy with each other, and it brings the community closer together. It brings humanity closer together. And going back to your comment about it's about the human, that's what this is about. Humans are the reason why we're here, right? I mean,
sure. Yeah, Henrik, I guess.
Yeah,
let's have some a bit more technical view. What do you think about the community as a?
Yeah, but we are running quite a number of energy communities, and I think I agree with what you just said. The idea is to use the energy produced locally, use it locally. There's no reason to take it to the high level voltage and back again. So that's where we save investments also in the grids, and we get cheaper electricity. And using the concept we have developed in these annexes with the flexibility functions and so on, we can have the flexibility function for the energy community and link it to more high level markets, and then based on the pool of different cars and so on, we can participate in existing markets potentially.
Yeah, thanks. I would like to conclude this part with the last question to all of you, and please be short. It would be just like short answer. So what, in your opinion, is the key solution for the future buildings and communities. So could we start like this? So Henrik, please, if
I should start again. I think the key solution or the key challenge we have is to map this static, deterministic block bidding thinking with the conventional market. And really, I have not really seen successful classical markets on the DSO local level. So we need to realize that we need at some level to go from this conventional market to automated solutions based on control theory and flexibility functions where things are just automated and invisible. And we just have an app with our preferences. So that's how we successfully unlock flexibility on the DSO side in energy communities and so on. So that's, I think, the key element to use this for flexibility functions and control theory.
Sure. What is Nicola's opinion?
Yeah, I would just say it's data access. At least in the United States, we as the researchers don't get access to the data unless you're the utility, and the utility likes to keep their data. And so we need better data access so we can unleash students, inventors, entrepreneurs to look at the data and actually provide solutions and implement this hierarchical solution that we're talking about.
Stephen?
So I think electric vehicles and hot water systems are no-brainers. You've already purchased the hardware, no extra cost, and so unlocking that is going to happen. I think that's a no-brainer. When it comes to, there are various levels of electricity industry services, and when it comes to sort of reliability and stuff, often air conditioning is at least 75% of total peak demand, and so air conditioning, at least as a resilience thing, I think is an essential one that will come through in time as well.
Thanks, Ian. So, Jan, your opinion?
Yep. From my perspective, it's explaining, telling, and demonstrating to the people that they have valuable assets in their household. Because if you are building a house today, you are not thinking about it as a flexible asset. And if you don't understand the economics behind it, then you don't take care about making it smart, making it connected to the grid and to the other players on the field. So I feel that like talking to the people, explaining and demonstrating that there is a value will change their mindset and will then make thinking in another way, and the utility providers, as we are, will start tackling these business opportunities. Then the business will drive the change because there is going to be some money and there's going to be some demand. So that's going to be that's the key missing thing, like the understanding of the concept of flexibility.
Thanks, Giuseppe. Wrap-up question.
Our point of view is to we believe that we need to upgrade our design work from near zero energy building to zero energy building. That means that we have to use, of course, batteries. We have to use, of course, hydrogen as an energy vector. We need to use a machine-to-machine interface on our power appliance. And we need to use a lot of communication with the prosumer. They do not understand when they have to use energy. It's 40 years that we teach them that they have to use power appliance during the night. They use power appliance during the daylight.
Thanks. Šárka?
The flexibility and energy community, it's not a disaster. And that's the thing we have to say to our citizens, to the people in the region. And on the side of Wunsiedel, we are region near to the Czech border. And we have to say to the mentality of the people there that flexibility and the new technologies are not a disaster.
Okay, nice. Thank you very much. And now it's space for you as well to ask some questions. If you have any question for our speakers, please, we have room like for 2-3 questions to be elaborated. I can see hand over there. Please wait a minute. My colleague will hand out the mic. Where, sorry?
Hello.
Thanks. Yeah,
thank you.
Go ahead.
Yes, thank you for space. I'm a student in FEL-CTU and I'm working on diploma thesis or community energy. And from my point of view, the technical problems are okay to solve. the main problem is the social problem. So my question is to Šárka: do you cooperate with some social, psychologists or sociologists? Because the biggest problem from my point of view is to explain to people how to act, and we have to change the mindset, as you said. But can we change the people's I don't know how to say. Sorry.
So basically, how to engage
yes,
the end user,
yes,
right?
how to engage in this whole new world, because as we heard, we learned people how to use energy at night, and now we have to learn them how to use it at daylight. Thank you.
Wow. It was a directed question, so Šárka.
Yeah, thank you for a question. I'm original psychologist. I studied psychology and also coach, so it's a quite nice topic for me. We cooperate with our authorities. That's the first thing I have to mention. The community and also our region are with us. And how you can change it in a small city, nowhere, middle in the woods, as to say them you can save maybe some money, and you will get sustainability. Your woods will stay green in our area. And you have to involve all the stakeholders, and you have to talk to the people. If you are not able to explain the solutions to the old lady, which she's shopping in Edeka or Lidl, you can forget about it. But if you can explain it, and it's the know-how of our company SWW and also of my boss, how to communicate this special topic. So you have to explain, you have to talk, and also make some research in the community.
Wunsiedel, you did some kind of workshops, or how does it work, like in practical way? You know?
Yeah, of course, a lot of workshops, and in Wunsiedel we have also an electrolyzer. And since we started with the idea to implement electrolyzer in our power plant or in the energy park, we made a lot of workshops for the citizens, for the municipality, and it's quite important that we have the political support from all sides, and we are in a cross-border area. So it's quite important to explain also to the people in region Karlsbad that you are building something, but it's okay for everyone. So we have some specialists in our teams. We have some social psychologists, we have coaches, and on the other side we have nice technical solution, green solution.
Thanks, Šárka. So short.
I'll be short. Through our energy equity and environmental justice work, one of the big things to talk to community-based organizations, and this is very simple, is you need to provide childcare when you have these events. That is as simple as it could be, but I mean, it really does work, because all of a sudden people can show up and listen and understand how their energy systems are going to change, and really listen.
Sorry, Henrik. There will be another question. I saw one more question, please. And there's third one. Yeah. We have as well second part, so save as well some question. There will be another round of questioning. So, yeah, thank you, Jan.
Hello, I'm Rosa. I'm working in VTT Technical Research Center in Finland. And we probably agree that the asset owner owns the asset and the property. But I would like to hear if you agree who owns the monetary value provided by the flexible assets.
Do you have any specific guess?
I would like to hear if you agree or disagree that the asset owner also owns the value provided by the flexibility asset.
So final, Henrik, you got the word. Maybe different question that you wanted.
But thanks for the question, and I fully agree. And I don't know in Finland, but in Denmark, the cost for balancing and so on are just extreme. Some of these companies doing the balancing and so on, trading and so on, are earning a lot of money. And I think the money belongs to us who provides the flexibility. And also, I think the cost for energy today, a couple of years ago, in August 2022, due to the conflict with Russia and so on, the price went very high, but now the prices are very low. So the main concern many of the people I have in my family is to how we can participate to the green transition. And actually, my mother, I have some problem in explaining her why the wind turbines often stop when the wind blows. Because she says when she was young, the wind turbines always were running when there was wind, but now it's the opposite. And I have a challenge, so maybe we can elaborate on how. Because she would really like to contribute to the green transition, but she can see that there are some challenges in the way it's implemented now.
Okay, thank you. I hope it was answered the question. Yeah, as well, Steven.
So we've done a reasonable amount of sort of customer research and things like that. And the primary motivator for participating in flexibility is the money. And so it's a voluntary deal. If you get a deal from the retailer that says, you know, we'll give you this amount of money for flexibility and stuff, you know, it's you can accept it or reject it, or you could, I guess in principle, you could ask for more if you're a big customer kind of thing. So yeah, there has to be some sort of sharing, and so the buyer of the flexibility from you, the customer, does need to offer you something to make, and what that is, that's a commercial transaction.
We have space for one really quick interaction.
Quickly.
So then we will maybe save it for the later time for.
So I totally agree. It should be the asset owner who gets the money from it, because then the business model will not work. Because if it's someone else, you go and buy a water heater, but someone else will get the money, and someone else will be like turning on and off your water heater, then the first thing you will do is that you will somehow sabotage it, and you will turn it off from disconnect it from the internet and so on. So I believe that there has to be incentive for the end user. And when I said the asset owner, we've been working with some banks on a model that you could get the asset for free. So for example, for the water heater, our calculations show that the ROI should be like 2 or 3 years. But the lifetime of the water heater is about 10 years. So if someone gives you the asset for free, then that's the person or the company who gave you the asset for free who's making the money. And then again, still the asset owner, you have it for free, but he gets the money. And then the business model works, and everyone makes money. No one is sabotaging anything, because it works, and there's money for everyone.
Thank you so much.
Yeah, okay.
May I state the question only? Perhaps it will be answered later. But I think there's an aspect which is missing at the discussion now. Yeah. And that is the business case, not for the customers or clients, but on a much larger scale. I will explain why. I'm from a photovoltaic community, from the Academy of Sciences, and in PV, making it success was done with 3 simple measures, which were done by law on much larger level. And those 3 were emission permits. The second one were net metering, and the third one were feed-in tariffs. They were all forced on the large players. They would not accept them without being forced, but they then accepted them happily, and the whole thing evolved. Maybe we need that also on this scale, and I will leave up to you if you want to answer it later.
Yeah, I'm sorry we are a bit behind the schedule, so I will continue with the second part, because we have still prepared amazing presentations from our partners from industry. So it would be pity to miss it. So yeah, let's dive into the second part of the Energy Flexibility Forum. Well, again, we have presentations of best practice. So you will see like the pilots and so on, what you shown in the beginning. And then we have few additional questions. I hope that we will go through properly. But now let's start with the presentation. So first, I would like to invite Jan Hicl to present their example from Delta Green.
Thank you. Thank you. So very quickly, as we are behind the schedule. So we did with a local TSO, we did a test with the households. So we are focusing on bringing the money from the flexibility to the households. We have, and in Czech Republic, for everyone to understand, we have some struggles with the smart metering. There is around 160,000 smart meters out there. We'd like to have more out of 6 million households. So the penetration is very low. That's what we struggle with. Only owners of PV panels have the smart meters. That's why we focus on the PV panels owners and on the batteries. So you know the future. You know, very aware of what's going to happen. And if we want to be on a path to zero emission, and if we want to achieve the zero emission at 2020 and 2050, then we should have around 92% of the energy from the renewables. Now, what's the big problem? And you're looking to wrong slide. The big problem is that at the year 2050, we will have around 70%. Around the world, 70% will be from the variable renewables. That's very important. Variable is wind and sun. And as we say, we are connecting the households to the breath of the nature. So we have to somehow adjust to how the nature is producing the energy, especially wind and the sun. Now, the question is, can we replace the big guys with the fossil fuel power plants with the households? Now, we did a big study where the flexibility is, and we find out that there is, of course, a lot of flexibility in fossil fuel power plants, but we don't want them. So we did the research in the demand side, and we find out that there is like almost 3 times more in residential sector than in the industry. And it's very logic, because I mentioned that 80% of your consumption in the household is heating and water heating. So the house heating and water heating. So these two assets consume around 80% of your energy, and both of them are flexible. And if you, at the top of the existing residential flexibility, if you add there the electromobility, so the EVs, then you get to like 6-7 times more than what you have in the industry sector. Of course, like controlling something and turning off or on something on demand in the industry is difficult. Now, what we do with that is that we connect these 4 assets that I already mentioned, so 2 heatings, so water heating, house heating, and then 2 batteries, EVs and the PV panels. We make big blocks that could be sold on the other markets. Doesn't have to be a TSO especially, it could be someone else. Especially utility providers are very interested in these flexible blocks, and we sell them. So we have to aggregate very small flexibility that you have in the household, and then we build up big blocks of flexibility. Of course, there is the predictability is a big part of it, and all the analytics, and so it's very difficult to aggregate it, especially in the households. And then we resell it to the other parties. Now, what we did with the local TSO is that we connect to them. They gave us the real AFRR signals where they say go up, go down. It was asymmetric, so 1 second is up, 1 second is down. It depends on what the situation on the grid is. They gave us the real signal, and we send it to the household. The block made of households. We had between 25 to 30 households with their batteries. The batteries were in the state as they would be. It was in a December night, so most of them were discharged. but some of them were charged. We were able to go up and down, and the signal comes to us every single second. Now, FRR, the standard for FRR is that from once you receive the signal, then you should be from 0 to 100% of your flexible asset within 7.5 minutes. 7.5 minutes. Why? Because most of the assets that are providing the AFRR are the big generators, and of course, like speed up the generator or make it more powerful takes time. But with a battery, like if you send a signal to go from 0 to 100, it's immediately. It's within a couple of seconds. And when we presented this chart to the local TSO, he was like, guys, we've never seen such a nice chart ever before, because we are used to work with the big assets, and it takes time. So this is very nice. We are really happy to see that. Controlling, now you might be challenging the number 27 in this special case, 27 batteries that we had in the block. Well, it's even harder, because once you have someone in the middle of the night who starts charging the car, then you have to balance their consumption. So it's very hard. If you have a block of 200, 300 households, then if someone starts charging their EV, then there is a possibility that there is someone who stops charging the EV. So the 27 was even harder for us to control, but we succeeded. Now we are building a solution that will bring this service to our 3,000 smart metered customers. From the pilot, we discovered that for the service up, for the service down, which means consuming the energy, we would need only around 80 households to be able to provide 1 megawatt of power. But for the system to be able to provide 1 megawatt up, we would need around 250 customers. And the estimate of how much would they get paid is around, let me do the quick math, it's around 20 euros a month they could make from the balancing services or providing their assets to their balancing. Now you might be questioned how much is going to be used the battery. It's going to be 1 cycle in 10 days on average. So that are the quick numbers from the tests which we did. Thank you.
Thank you very much. I would suggest that we will discuss this all together, if you don't mind. So we will finish the presentations and we will go directly to Evergreen. Giuseppe, please, could you tell us our solution, and then we will do the wrap-up together.
First of all, many thanks for having you all here. As we said before, we design near zero energy building and zero energy building. Our point to see local and flexible and local flexible energy is a little bit different, because first of all, a near zero energy building use, let we say, 20% of the traditional building in terms of energy. And a zero energy building is a new generation, will use 10% of the energy as today is used in a normal building. That means that the consume of the building for heating, cooling, and hot water system never overpass 30% of the total energy that we need in each buildings. In this picture, the consumer or the prosumer are very important, because the building has a very low consumption. The prosumer or the tenants has the bigger part of the consumption. And we have not to talk about electric vehicle. They are a trouble for everybody. So we show here something that you see and you know very, very easily. Sorry. We have, like you understand every day, the daily consumption curve, the production consumption, the production energy of every day. That is quite normal. In the past, let we say in the last 10 years with the batteries, we get the chance to have every day a part of the energy that was not in a self-consumption storage in the batteries and use it during the night time. But the building was always asking to the grid to get power there. It's because the cost of the batteries was very high, and because also the performance of the building, of the design work we done in the last 12, 15 years was not so high. As today, what we made, we collect for 6 years the consumption data of buildings in Switzerland, of 5 of them, and every 15 minutes, dividing the consumption of the building and the consumption of the tenants. So we make a model with the University of Lugano that show us during the year what we are going to do in theoretically in a zero energy building plus that will have the goal to produce energy for the building, for the tenant, and for the electric vehicle too. Okay. What you see is that this is the production we have with the photovoltaic all along year from January to December. The photovoltaic is very much improved. We use also vertical wall inside the buildings because we need a lot of energy. In the first 3 months of the year, we have to use a stock of energy that came from batteries and from hydrogen. In between March and June, we produce and stock hydrogen as an energy vector. In the summer, in between July and September, we still provide energy to the grid because we cannot do nothing differently. And when we arrive in this October to December, we need to use our energy storage. We use H2, and we produce energy again from using hydrogen. Here you see exactly what is the curve of our vessel, okay, about hydrogen. The experience we have, okay, first of all, electric vehicle. We are now starting with our Spanish partner to use vehicle-to-grid technology. That means that, for example, in Switzerland, that is a different market than European, we as today has every 10 tenants, 3 electric vehicles is a lot. It's much more than in Europe. And they create trouble during the night because we have to charge them. And they are not generally at home during the daylight because they are running around. So we have no chance to charge the electric vehicle with the photovoltaic fields. We are using the machine-to-machine interface, and we provide the tenants the chance to drive them a power appliance and decide when they have to run. And I will tell you one thing. We offer them kilowatts for free if they use during the daylight. You know what's happened? They do not use the kilowatt we gave them for free. They don't care. So we are talking about philosophy, about psychology. We offer them just during the daylight kilowatt, and they do not use. Okay. What we do also is we try to drive our heating pumps and mechanical ventilation with more power during the day when we have the sun than during the night. And at the end, we move a lot of communication on the consumer with very, very low results. I would just drive you to the last chance. This is the pilot we are going to build in Switzerland in the next 24 months. It's a building with 10 apartments that will have 250 kilo of hydrogen storage in a vessel that we say 7.5 megawatts hour power, 80 kilowatt power photovoltaic, 250 kilowatt of lithium steel batteries, and of course, water-to-water heating pumps, because we are near to the lakes, we have a lot of the opportunity to use the heating coming from the water. We use M2M control power appliance. We have 2 electric vehicles that will be shared inside the condominium and that we use in a vehicle-to-grid mode, so we can charge and discharge. The only issue we find out to charge the electric vehicle during the night, as today, is charging the batteries, the building batteries during the daylight, and when we have a lot of energy in our power, in our batteries, charge the electric vehicle that arriving in the garage in the evening or in the night. Smart air conditioning and energy community, of course, because that is the big part of our issue. No more. And everybody is invited in Switzerland in 2 years' time to see the building that is running. Many thanks.
Thank you very much. Thank you very much. Again, we will discuss everything together, and I would like to invite Šárka to present the experience of Wunsiedel, right? This is the pointer.
Okay. So thank you for the time. This is our power plant. You can see behind me on the screen. The blue part is our hydrogen electrolyzer, and the main part of our plant is in the middle. So the next slide, it's working. It's the combination and connecting between the technical part, between the power plant we have, with the industry, with the IoT, and also with the community. And this 4 parts, it's the energy community of Wunsiedel and of Wunsiedel district. It's not only the city of Wunsiedel, it's also the district, because we have some power plants near Wunsiedel, which are also supplied from Wunsiedel and which are managed from Wunsiedel. So, this is what we were doing in the last years till 2001 till today. And you can also see that there are a lot of plans for our future, for the future of Wunsiedel. And these are the 4 points I already showed you in the slide. It's our energy from the renewables, the storage for the municipality of Wunsiedel, energy efficiency, which is saving our grids, our batteries, our hydrogen, etc. And IoT, we can't forget about digitalization and managing and data-driven storages and management of the whole community. And of course, we are selling heat and power to citizens, and the citizens are selling these products to us. So the part of our energy community are also the business models. But I think you want to see some numbers, so you can read it on the slide. And I hope you will also get the presentation after this meeting, right? Or not? Okay, thank you. So it's today and our plans for the future. And about the business models, it's our structure. We have SWW and also some companies which are responsible for the parts of our energy community, because of it would be too huge and too complicated. So we have one part for wind, one part for sun, etc. And we are here we are part of one project. I think it's called Glocalflex, and SWW and SGET, and we all are involved in this project. So I would like to show you the German pilot of this project. We are there with the Technical University in Dortmund in touch, and also the pilot in Wunsiedel. It's a multi-stage pilot you can see with laboratories and also the application on site in Wunsiedel. I think I was quite short, but thank you for your attention.
Thank you very much. Of course, I prepared some interesting questions from my side, but I think more important what you think and what especially you think. So let's maybe now continue with some kind of free discussion. I kind of steal the space for your question for the pilots, and now it's your room. Select whatever pilot you are interested, and please give us our feedback.
Thanks for a very interesting presentation. I think one question I have for at least the last two presentations is also in Switzerland you have this water-to-water heat pump, and you are considering the biomass district heating. So the way we try to solve the seasonal storage problem, of course we also have power to X, but hydrogen is still for us a bit complicated to store or expensive. So what we simply do, for instance, in the Copenhagen area, is we are using the district heating system for seasonal storage. So we simply dig a big hole in the ground in Copenhagen now, where we store the heat from summer to winter. So my question may be to your case, since you have water-to-water heat pumps, do you have the district heating in your? It was not really clear to me. And the question to you, Saka, is do you consider seasonal storage for district heating, seasonal storage?
No, it all is 12 years that we use geothermic. Okay. We do not have always the chance to use the water. In this case, the building that will be pilot in Lugano will have the chance to use the water of the lake. We pick up the water at 42 meters deep, and we recover and give back the water at about 37 meters. So we have 7 degrees fixed about all the year time. But the issue is the heating pump use 15% of the total energy of the buildings. Because the buildings, if it's zero energy standard, do not use a lot of energy for heating, cooling, and hot water system. The opportunity we need to supply today is the consumers, the tenants. They are 70% of the consumption. And the models we have are very precise as today. So we are local, we are local, because we know that we have to stay in touch with the grid, and we need to stay connected to the grid. But what we believe in at Evergreen is that we have to design buildings that take care themselves of the tenants that live inside or of the producers that are inside. We are developing a design work for a pharmaceutical company that uses 72 gigawatt a year, 24 hours a day, 365 days a year. So the trouble is completely different, but the point is how to do this. And we have not the solution yet. The pilot of Lugano will give us a lot of answers. We will monitor the data with the university for 3 years after we will start up the pilot, and we'll get new numbers that will drive us again to get new solutions and provide new data to everybody.
Thanks. Would you like to add something?
Yeah, SWW is also a provider for gas. So we are selling gas to our customers. And if we would provide also heat to our customers, it would be across our business. So, but there are some plans for the future. We have a real big hole in the near to Wunsiedel, and there is a plan to fill it with water and store the heat and the energy in the water, which should be covered with photovoltaic. But it's the future. It's not the today situation. It's the future.
Thanks. Nicholas, yeah, do you have any feedback to anybody of
Sure, so Jan,
pilot?
thank you for your presentation. I really like the idea of a power purchase agreement, giving people the systems, basically. It sounds like that's the equivalent, right? Like, here's a heat pump, we own it, but it lives in your building, or keep you warm and comfortable. I thought that was great. But my question, though, is more on the commercial, the non-residential side. So as you're aggregating thousands of buildings up together to do their analysis, how are you handling the larger commercial buildings, a pharmaceutical unit, for instance, that uses, megawatts in demand?
We don't. No.
Simple and quick.
No, we have two divisions in our company. We are focused on the residential sector only, but then there is another part who is tackling the commercial part, and it's always they have to go there, they have to install their device, explain and calculate the business model for the future. And then, of course, it's very sensitive for the business operations. So usually we end up with the big freezers, which are not that sensitive to the temperature change. So if you change it for 1 or 2 degrees, it doesn't really matter because it has no influence on the goods stored in there. But the amount of the energy which could be used for flexibility is really huge. So we usually work with that, or with other like mills in different industries where you have to mill something for 8 hours a day, but it really doesn't matter when. So this is the way how we tackle that, but it's another division we really focus on the households.
Thanks. Stephen, any idea?
So I'd love the presentations, and I sort of see different perspectives on what the future might be. So I'm interested in your ideas of how this is all going to unfold. And just as a bit of context, I sponsored a bit of research where visionaries sort of did a quadrant diagram. You're doing it for profit, or you're doing it for the public good. That was on the x-axis. You were the big end of town, or the small end of town on the bottom. So bottom right was community. We're going to change the world. I think top left, it was big corporates. Top right was big government. And bottom left was small entrepreneurial. So we've got a perspective from small entrepreneurial. We've got a very community-oriented thing. How do you see this evolving? And sorry to make it into a big question, but perhaps if a dominant car manufacturer, for example, came into the market and they took control of their cars with their proprietary algorithms, where's this world going to here, I guess? Big question, I know.
Giuseppe, yeah?
I would say that the philosophy we use is we are money-driven company. We never design project that ask for subside. So if something works because the government pay for, we don't do. Our approach is very straightly. We just design something that have a payback. Hydrogen as today has a lot of trouble in payback. Everybody has to know this. So for example, Switzerland do not provide any peanuts if we use hydrogen. Germany pay for if a kilogram production. Italia pay for a kilogram of H2 produced. I don't know other country in Europe. But we have also a philosophy. For example, a lot of industries today need to have a carbon footprint 0, and they have to pay for. So they will use hydrogen in any case. But I gave you another example. Airport. Nobody thinks that an airport is a very heavy user in terms of energy. So, for example, we are designing a system for airport in the south of Europe that will have the chance to exploit about 1,500 hours of sunshine a year. And the idea of this airport is produce during the day a big part of the energy, converting in hydrogen, and using the hydrogen as energy vector during the night in a 12-month period. Thanks to God that they are in the south of Europe, so they have a few days of water and a lot of sun. So also in December and in January, they achieve 50% of what they need. And in this case, you can do something that probably not at 25 cents, but probably at 60 cents a kilowatt, provide energy that is carbon zero.
So for you, the future is driven by the economics, and it will be what it will be, rather than guided by any light. Does anyone else want to share on who's driving that future and where it's going to go?
Well, me personally, I'm driven, and that's why we joined the energy sector. It's driven by the good cause that we can change the energy system and we can reuse the carbon footprint. That's my personal thinking. But if you ask people if they would like to buy green products or eco products or whatever, they of course, most of the case will say yes, we would like to. If you ask them, would you buy it for 20% more, then you don't ask them. If they ask them, they say yes. But if you put on a shelf two different products, one 20% more expensive, then they will not buy it. And that's what I believe. If there is no financial incentive in what we are doing, and if people don't see that financial incentive, then it's not going to work. And I believe that carbon capture and storage is a nice example of that. It's a nice technology that could save us, but there's no business model behind it. So it's very hard to scale it, and it's very hard. We have the technology to save the carbon footprint, but we are not able to scale it because there is no business model. So if there's no business model, so I'm a big believer in business models and business in general. So that's my point of view, even though my motivation is a bit different.
Yeah. I think I will maybe give a space to you to ask any questions, because we have few last minutes. Is there any question for over here? Please wait a minute for a mic so we can hear you.
Thank you. I want to ask about the transactions. It was mentioned several times here as well, like blockchain can play a role. And I remember a few years ago there was a hype that every problem will be solved by a blockchain, and we see that this is not the case. But there are some cases where blockchain is valuable. And do you think that for the flexibility, blockchain is a key element? Is it enabler, or is it a two-sided sword? Because it also provides some complexity and even already complicated task, like it was discussed today, how to explain it. And if you add some blockchain on top of it, maybe you just go in the opposite direction.
Okay. Thank you very much for a very interesting question. Henrik, yeah?
Thanks. Yeah, I agree. It's a very interesting question. We tried a lot with blockchain some years ago, and I think the conclusion I have today is that if we have an energy community with a few large industrial players or things like that, blockchain is a possibility. But for normal household and more complex energy communities, I don't see this as an option. Then I more consider this dynamic pricing and so on as the solution today.
Oh, Klaus, please.
Yes, so I would like to comment on that. So basically, we are also studying blockchains in a larger scale and did some experiments on VTT. So my personal, let's say, understanding about this is that it could be used efficiently, at least in two places on this kind of energy, let's say, flexibility. And the first use is for identification of devices. It's very efficient, and also it is very good, and it goes hand in hand with the GDPR regulation. So it can be used there. So you can create a DID-based identification system that is valid for everywhere in Europe. So we are working towards that goal in our project. The second use is to use blockchain-based currencies for, let's say, to transfer these tiny little profits you're making on energy trading, if you are trading small batches of energy. So that is almost cost-free mechanism of, let's say, making money transactions. Like if you are trading like a few kilowatt hours and you gain like 50 cents, and the banking system takes you away like €5 of transferring this 50 cents or whatever to your account, so it's not feasible. So let's see into these two parts, we could be using blockchain-based solutions efficiently.
So we don't have clear answer. Nicholas, please.
Well, just adding to the blockchain discussion, I think one aspect that's nice about blockchain is that no one owns it necessarily. With the distributed ledger, everyone gets access to it, everyone can see it, the transparency of it's nice, and there's no one company potentially that's overseeing and saying, yes, this is our protocol, this is our implementation of it, right? It could be everybody's. So it does provide this transparency, free look at the transactions. But it requires energy to do blockchain. So maybe that's embedded flexibility by, never mind, by not using it, yes.
Do we have any more questions from the audience? Over here, please wait for a microphone.
Thank you. I have a question regarding the flexibility market for the residential housing, and my question is: will it happen fast enough? And let me explain. The thing is, I noticed that one of Czech utilities is already starting. When you want to connect a new house, they give you a little part of your electrical cabinet, a little switch box, which allows them to turn off some parts of your energy system, like a photovoltaic plant or a heat pump. But this is, I see this as them saying to you that you will participate in the flexibility market, whether you like it or not. And it doesn't take into account everything what was said here about satisfying the requirements for heating and so on. So my question is, what will be faster? The utilities covering their needs and their grids in this way, or the flexibility market where you can voluntarily enter? Thank you.
Okay, thanks for a question.
Thank you.
Jan,
yeah, one utility provider or several utility providers that they install to your household basically a switch that they can turn off and disconnect you from the grid. This is on the distribution level. They can do that, but it's just for emergency usage. It cannot be used commercially. So that's the first thing. Now, do we have enough flexibility? Yes, we have. We have a lot of fossil fuel power plants for now. Now they are announcing they are closing because it's not anymore profitable. So we'll be losing them. There is still enough flexibility, and everyone is focusing on industrial flexibility because that's the low-hanging fruit. You just install a big box there, and you have a lot of flexibility. But the future, and we see it from all around us, the future will be in the households. Now, will we be there soon enough? Well, we, as a company, we hope so, because that's a great opportunity that could be tackled. But we are adding a lot of inflexible resources or sources of energy, meaning wind and sun. We're adding to the grid, but we don't know how to be flexible on the demand side yet. So we have to do this kind of events where we explain to the people what the flexibility is, how to be flexible, and of course incentivize them and tell them, hey, if you will be flexible, you will make some money. So hopefully we will be there, and I think we will. There are another projects across the Europe who are tackling this, and controlling electric cars is very easy. And I think that the electric cars will be part of the system. So I believe that we will be there on time, but there might be some blockers around the way.
Any comment? Oh, maybe let Steven tell the experience from other side of the globe.
So if the question is, do we need flexibility markets or what's their maturity? In some ways, we already have a flexibility market. That is just the ordinary market. So if you, and again, I go back to sort of the two ways of looking at flexibility. One is just to manage your loads and reduce your overall energy bill, in which case you're just using the existing market, multiplying the amount of consumption and reducing it when the prices are high. Then in Australia, because of the large amount of solar photovoltaic, we have more interventionary sort of systems. Is it a market? But at least, I'm not sure whether it's a market, but it's a at least a mechanism of management there, where the networks are putting out dynamic operating envelopes. That is, at this hour, we allow you to export this amount of PV into the grid, and and that goes up and down based on constraints. So that's a physical management, not necessarily a price settlement type thing. And there are other sort of ways. So it's a very complex question to answer. I certainly am very keen for independent markets where there's transparency for the customer to be able to take control and be a prosumer, and that's going to take a bit longer, which is probably where you were going.
Last comment from Henrik.
Yeah, I think we need to support energy communities, and which was also behind this interesting project that you want to go in this direction. And I think one of the challenges we have, if we consider residential homes, is that the energy price might be today maybe zero. I didn't look it up, but due to there's a lot of sun also in Denmark, so it might be very low. And on an average, I would say the energy price varies. If you have a varying energy price contract, most of us have, I think, but it's up to 50% of the total energy bill. The rest in our country is energy taxes and tariffs. So 80%, 85%. Now I should be careful in the calculations here, competition. The 85% is constant. So the signal is basically not visible. So in order to activate and use these technologies, which looks very promising and interesting, I think we need to talk to the regulatory bodies and so on to implement new tariffs and taxes all over Europe. Of course, maybe Denmark is the worst example, but I think I know other countries where it's also pretty bad.
Thanks. I think we can conclude is that we have still some work ahead. Still something is unclear, and then we need to explain. So thank you very much to attending this flexibility forum or energy flexibility forum, and hopefully we can repeat in some time period. So goodbye. Enjoy the evening.